All right. I'm going to go over the code from the last 2 weeks, and then we're going to design a database together. For those of you who are watching this for the first time, this is the 5th time I've tried to start this, and I just want to get into it. All right, so joins, taking tables, putting them together, because that's what the data exists in multiple tables. If you guys remember back to 2nd grade, we used to use things called sets, and we had Venn diagrams, right? So bring out the notorious MS Paint. So the Venn diagram is this. We had one circle here, and then we had another circle here, and one circle was blue, one circle was blue, and one circle was yellow, and the middle was green. So we had everything that was in set A and everything that was in set B, and in the middle here was the stuff that was both in A and B. Am I bringing up perfect memories from 2nd grade? Excellent. So this is basically how joins work in databases. But the first one we're going to talk about is the simple one. This is a command called union. All union does is it takes data from one table and another table and puts them together in one result set. There's no rhyme or reason to it. There's no elegance to it. It's just brute force. So if I do this, I'm going to take first name and last name and the word customer and call it role. And I'm going to union it from customer and take the same thing from actor. And I'm going to run this. And that's what I get. I get everyone from customer as a customer. And I get everyone from actor as an actor. And that's pretty much it. Or staff, but okay. Here's the thing though. If I change this last name to, I don't know, actor ID, and I put that there and I run it, it still works. Let's get down here, and all of a sudden there's no names, there's just IDs. So this is just a brute force way of joining information from two tables to get something done. So this would be done if you were like, I try to think of real world reasons why you would do this. And one of the reasons would be like, let's say you owned a bookstore and you just bought another bookstore and you wanted to merge the inventories really quickly and you both had a books table. You could do a quick union between those tables and put it into another table just to see what's there. It's not elegant. It's just brute force. And so when we do this here, when I run this again, you'll see we get 799 rows returned. Okay, because we're using union. The one thing union will do is it will not show you duplicates. So if it exists in both of them, it won't show them unless you do union all. And then notice it's 800 rows returned. So union all will give you the duplicate. If you're ever going to be DBA, you're probably never going to use this. If you're going to take the quiz this week, you need to know this. Then we get our first simple join here. Our first simple join is called an inner join. Real quick here, all this is we're just adding order by. And if we do order by, it's got to be the names of the first part here. So when we run this, it just puts in the order because it orders by that. Okay. So that's just not fun. Okay. Our first join, our inner join. Our inner join is when we're getting this green part here. So we want to get the data between two tables that exists in both tables. So we use an inner join for that. And to make that happen, we give the name of the two tables, and then we give a column on which to join it on. So we're going to get the distinct first name from actor. We're going to join customer to it, and where the first names are the same. So we're going to find out where all the first names are the same between actor and customer. A couple of things you're going to notice here. First, I've got these letters after the table designations. These are aliases. Okay. When you're writing join queries, you've got to tell the query where this column came from. Because if I run this right now, it'll be happy and give me results. If I take this A away and try to run this, it's going to give me an error. Column first name is in field list is ambiguous because it's in two different tables. It doesn't know which one to get it from. So we've always got to make sure that our column names are qualified in a join statement. If you didn't use these aliases, you'd have to type actor first name or customer first name to put these aliases here so we can just do it real simple with a letter. It can be whatever, it can be AC, whatever you want it to be. But whatever is after this is what the table will be known as going forward. So here we're going to join on the first name from the actors table and the first name from the customer table and just interjoin and get everything that's there between the two. We can also take a subquery. So let's look at this again. Yeah, so we can also use a subquery in our query here. And I made a nice complicated one here. I've got a union. So I'm getting the first name, last name, and staff from staff. And I'm unioning it all to the left from customer. And I'm calling that table combined. So the result of this will be referred to as combined. So I want the first name and the last name and the role from combined left joined actor, where first name is not null. So when we're talking about left joins, okay, so this is an inner join. When I ask for a left join, I want everything from this table, because it's on the left side, and only the things that match from here. So we're going to see a bunch of nulls if I run it without the null. So I want everything from here and only the things that match from over here. So let me run this 2 ways for you. If I'm going too fast, let me know. So I run this here and do it where it is not null. And I get 205 rows returned, and I get the actors, and I get the customers down here are the ones that are the same in both. If I take out this is not null here, take out this where clause, and just run this, I get this, and when I get down here, I get all these nulls because there were results from the right table, but they don't match. So because I asked for the results from the right table on a left join, it's going to show me all the stuff that doesn't match too, but it's going to give me the left side result, which is all null. So in the first time we had 205 rows returned, that's where there were 205 names that existed in the actor table that also existed in the customer table, where there were 2 of them. But now I'm returning everything. But I'm not returning, since I'm only getting the names from combined here, from the actor table, there's nothing there. Does that make sense? We'll do more left join. So if it doesn't quite hit with you right now, we'll dig more into it later. Okay. We also have 2 commands. Now, these commands didn't work 3 years ago, but they work now. There's intersect and there's accept. So intersect basically does what an inner join does. So here, I'm going to intersect the first name from customer and the first name for actor. So it's going to return everything here, but only that matches here. And I get 73 rows. There's only 73 first names that are in both tables. If I do accept, it's going to show me everything that's in here except what's in here. So if I run this, and now 570 rows returned. So there are 597 names in customer that are not in actor. Make sense? Sort of, kind of? That was week 4. Any questions on week 4? We've gone back in time. Going to week 5. If I'm going too fast, please stop me because I will burn through this stuff really quickly because I understand it. I don't want you guys to get confused and run away screaming. All right. Now we get to complicated queries, multiple joins, and all other sorts of fun stuff. This is a cross join. A cross join is never a good idea. It does something really, it's called a Cartesian join. And the reason it's called a Cartesian join is I'm getting customer first name and customer last name and film title from customer, and I'm joining it to film. So what's going to happen here is it's going to pair up every customer first last name to every film title. So let me just show you the results there. So it's going to take a second for this to run. Notice this says fetching. It returned 600,000 rows. Because when you look at the results set, I've got Austin Citron, who's an Academy dinosaur. And if I go down to the next one, so every actor is going to be attached to every movie in a cross joint. So he's in Goldfinger too. And if I look down here, he shows up in every movie. So what this does again, a cross join takes every entry here and pairs it up with every entry here. So it's just exponentially huge. I've never found a practical reason to do this other than it's kind of like, when you're camping and there's someone you want to mess with and you send them out for a bacon stretcher. That's what this is. This is the SQL query equivalent of a bacon stretcher. Because this is never a good idea. So here, next query I got. I got 3 inner joins. I think you can join up to 12 tables in one query in a join. And that's showing off. So don't ever do it. Because the more queries you join, the longer it takes to run. But here I'm getting customer first name, customer last name, and then the title of the film. From customer, I'm joining customer to rental, and then rental to inventory, and then inventory to film. Because I'm trying to get the film title. The film title is only in the film table. So I've got to find the track to get the film title out. So I want the customer, it is like 7 degrees of Kevin Bacon. So how do I get the customer name and the film title out? Well, customer can join with rental because rental tells you what movie was rented. Rental connects to inventory because it tells you what the inventory ID of the missing rental is. And then inventory joins to film where the film name is. So I'm joining rental on customer ID to customer. I'm joining rental to inventory on inventory ID. And then I'm joining inventory to film on film ID. So when I run this bad boy, it tells me who rented what. Now, notice that in my select query, I only have stuff from customer and from film. I have nothing from rental and nothing from inventory. It doesn't matter. I don't have to have the stuff there in my select query. I just have to give it, this is the path for the query to find this data and put it out for us. Okay? With me? Most excellent. All right. So here, because we want to make things even crazier, we can interjoin on a subquery. I have first name, last name, and then rental summary from total rental from customer, and I'm joining this query where I'm getting the customer ID and how many rentals from that customer. From the rental table, I'm grouping it by customer ID and doing the order by total rentals, but I'm only getting the top 5 results. And I'm calling that rental summary. So what I'm doing is I'm creating a temporary table that gives me the customer ID and how many rentals they had. And then I'm joining it to the customer table to find out the first and last name of the person and how many total rentals they have. And I'm joining it on customer ID. So when I run this, I get my top 5 rentals. If I get rid of the limit 5, it just gives me another 5. Make sense? Now, there is I don't know if this question is there anymore. So there used to be a question on the quiz about why would you join a table to itself? It seems like a weird thing to do. But in certain cases, it makes sense to. Practically speaking, you have to have the data set up in a certain way for it to happen. But here's an interesting approach to this. So we've got the actor table, right? I want to find out how many actors share a last name. Okay. So in order to do that, I've got to join the table to itself. So here I have select A1 as first name as actor 1, A2 as first name from actor 2, and then A1 as last name. I have actor as A1 and actor as A2. I've got to alias them differently because I'm creating two different copies of it in memory. Okay. And then I'm getting where the last names match, but the first names don't. Does that make sense? Does that query make sense? So when I run this, I've got Penelope and Sean, whose last name is Guinness. Penelope and Ed, whose last name is Guinness. Nick and Daryl, last name Wahlberg. Ed and John, last name Chase. So practical applications for this, few and far between, but sometimes you do need to join a table to itself. Any questions on the code? Everyone good? All right. Because you three have got my undivided attention. Anything you ask, I will answer. The rest of the class can, step off because they're never here. You guys are the rock stars. All right. So let's talk about designing a database. Okay. So when I design databases, I basically pick the topic I'm going to do. And then I pick one table I'm going to make, and I start filling out that table. Then I look at that table and make sure that it's normalized. And then I move on to the next table, wherever it leads me to. So the first table I'm going to start with, we're going to do a database based on tracking away missions for Starfleet because I've been contacted by the Admiral of Starfleet to make this database. So we're going to do this. So the first I'm going to start with is crew because we've got to have crew on our missions, and expect a lot of segues in the conversation tonight. So what do I need to know about my crew? Well, the first rule of normalization is every row, every table must have a column that's an ID column. Don't make a crew ID. And I'm not going to do the default name because I'm going to be crew ID. Then we got to choose the data type. Now, here is segue number 1, choosing the data type. Many people don't think choosing the data type is important. They are wrong. Choosing the data type is incredibly important because choosing the data type has a direct result on how big your database is going to be. And I'm looking at you and you're wondering why. I'm going to tell you. Let's look at the int. Let me get my notepad up here. Okay. So let's look at int. Int is any integer between negative. I'm going to make up numbers here. I know the exact number, but you'll figure it out. Okay. So it's from negative, I think it's like negative 2 billion to positive 2 billion. I never remember to look this up because it's like a very specific number. It's like 2,621,000, whatever it is. So we'll just do it this way, right? That's a big range. And this is 16 bits. This is a 16-bit number. Okay. So it takes up, so every row that exists in a table that has an int data type in it automatically consumes 16 bits. And you're thinking that's not a lot. Well, think about a table with, 17 million rows. It becomes a lot, right? Okay. So that's not the only type we have for integer. We've got tiny ints. We have small ints. We have, and then we got big ints. Now let me make sure I got small here. So we've got ints. We've got, there's big ints. Oh, there's medium ints. And then there's tiny ints. So what do I call it? MySQL has medium ints. Now, here, 2, 4, 8. So here we have tiny ints. And tiny int is negative 256 to positive 256. And it is 2 bits. Okay. Small int, I think, is like negative 512,000, positive 512,000. I preface that I'm making these numbers up, so if you look them up, you don't call me out on it. I'm just giving you the general idea of what these are because no one really remembers. And then medium int is something like 2.2 million, negative million, positive 2 million, and it's 8. And then big int is huge. It's just ridiculous. It's every number under the rainbow plus 6. Okay, it's a Googleplex. So here's a true story. I used to work for a company called Property Insight. The company was a title insurance company that they would do research for title insurance. And they had databases from every county in the country. And people would come in and they would buy the plot maps when they were researching titles, right? And when they designed the database, I think it was in 1980 something, they had an ID column for their sales table, and they made it an integer. So it's up to 2 billion, right? And they said to themselves when they made the database back in the 80s, oh, we're never going to reach more than 2 billion entries in this table. We don't need to make it bigger than 2 billion. And I really don't think that they did that. I think I'm just giving them credit because whenever you design anything, the default is in. End of story. It's just in. So fast forward to 1990. When was I there? 2003, 2004. Fast forward to 2004. I'm working for the company. And I look at that table and I see that it's an int. And to my surprise, the int column the highest number there is 1.995. It's 1,995,000,000, blah, blah, blah. They're about 50 million away from outgrowing the int. And what happens is when you run out of integers, you can no longer insert it into that table. And it stops dead. So we had to do an emergency fix where we converted that column from an int to a big int. Any guesses on how long that took?
I'm assuming a really long time.
Yeah. Give me a guess. It's in days. Give me in days.
Oh, days? I don't know, like 60 days.
It took 5 days. It took 5 days.
Okay.
In a retail environment, 5 days is death. So we had to pick a holiday weekend where we had Friday, Saturday, Sunday, and Monday. And we took the database offline Thursday night at 5 p.m. And by Monday morning, 10 a.m., it was back. The size of the data of that table had doubled because we went from a 16-bit column to a 32-bit column. And the reason why it took 5 days is that it had to go every row, change every row one at a time in the 1.9 billion rows. So it was a long, ridiculous process, and I had to sit and watch it the entire time. So, well, I took naps here and there, but when you're the new guy on the block, you get to do the fun stuff. So that's why it's so critical to choose the right data type when you're doing this, because you don't want to have a column that's going to blow up your database. Because if you're doing an age column, I don't think int is the good choice. That we don't have any Methuselahs anymore. We all around 80. I'm shooting for 250 myself. So I want to break into the small int category. For me, I want my age to be that, and then I'll be happy. But I like to make the tail end of tiny int. So if we're doing age, we'll probably use tiny int. If we're doing an ID for a column and we plan our business to grow, we're probably going to use big int, depending on how big our company's going to be. But it's important. So the other thing is when you're looking at there's varchar and char. Okay, varchar will always have these will always have parentheses with a number in it. Now there's other. I mean, this isn't the only number one. There's decimal. There's money. There's date time. There's all sorts of numeric ones that have specific sizes. There's date. There's time. There's date time. But char and varchar are the ones I'm going to talk about specifically here because there's a distinct difference between the two of these. So they both store up to 33 characters. That's what the 33 is for. And it can go up to 256. And if you're in SQL or Oracle, you can use max, which is as big as it goes. But the difference is if I have char 33, every row that exists that has that column in it will have 33 character spaces taken up, which is about not 33 bits, but let's call it 64 bits, somewhere around there, taken up on it, no matter what's in there. If it's 33, if char 33 and you've got the word bow in there, it'll be 3 letters. If you got 33 letters in it, it'll be 33 big, no matter how many letters are in it. Varchar will only be as big as what's in it, but will only grow to 33. Does that make sense? Y'all notice that I like talking about this a lot more than I like talking about code. All right, so back to our show. So crew ID, we'll probably leave it an int. Starfleet's pretty big. We might have 2 billion people working for it by the time we're done. So we'll leave crew ID as an int. Our next column is going to be name. And we're going to make that varchar 45. But let's go, because there's some really long names. We're going to go max that, go 256. Make the big names there, right? And because it's var, I don't need to worry about, taking up too much space. It's only the space of the name. Next, we're going to have rank, because that's important. And rank is going to be varchar 45. That'll be fine. And then we'll do species, which is important to know what species they are. And we'll keep that species went away. Okay, and I'll say varchar 45. Now over here, we've got, this is primary key. This is not null. This is unique. I forget what the rest of these are. They don't exist outside of MySQL, so kind of AI doesn't mean AI. Just don't. That's not what. That's not. Doesn't mean AI means. Then we're gonna have department, and we'll keep that varchar 45, and then survive. And we're gonna make this one. We're gonna be. I want to make this one. Okay. So bit is 1 or 0. on or off. And we want to do default. Default expression is going to be, we're going to default it to 1. So we're going to assume that everyone is alive when we're done with when we're done with the mission. Okay. Now, we have met with this table. We have met the. I want this to be recorded. And I want this to go away. So we have met our requirements for data integrity 1. We don't have any. We have a ID column, and because this column is a primary key, this one here. This one is a primary key here, right? Primary key means a couple things. Number 1, it can't be null, and 2, it cannot be duplicated. So that can only exist one time. If the number 16 is there, it can only exist once in the entire table. Another part of data integrity is to make sure that people putting data into this database cannot screw something up. And the surest way to have someone screw something up is to allow them to type something in. So we don't want to give them that ability. We want to lock them into, and I also want to lock them into like specific things so they can't add and get creative. So they can't give themselves a rank of like super awesome general 3. We don't want them making up ranks, right? So let's look at this. So let's look at the rank here. So I got a rank table. So I want to make sure that they can't make up a rank. So I'm going to create a table that's a rank table. Okay. And we're going to call this rank. And we're going to give it a rank ID. Now, are we going to have 2 billion ranks in Starfleet? I don't think so. So we're going to drop this to tinyInt. I think that's where we want this to live. 250 rank, 6 rank sounds about right. We're going to give the rank a name. And I'm not going to think about anything else right now. So, what do I want to know about the crew and the rank? Do I want to put the rank ID right here and just link these two tables together? Well, let's think about this. One crew member can have many ranks in their lifetime. One rank would have many crew members. So I can't really have them connect on a one-to-one relationship, right? Does that make sense? So I'm going to join them together in what we call a many-to-many relationship. And that's this little guy right here, N to M. So if I choose this little guy right here, and then I click him, and I click him, it gives me this fancy table here. So now, one crew member can have multiple ranks, which makes sense because one crew member, as long as they stay alive, will have multiple ranks in their lifetime. And what I need to know is, what do I need to add here to make sure I understand when the crew had the rank? Date received. And I will change this to a date. Okay. So now I can find out what crew member got what rank on what day. So I'll know during which mission what their rank was. Make sense? You'll also notice that I don't have a rank has crew ID here. But when you look at rank, the little key here is yellow because that's the primary key. And the little key here is yellow because that is the primary key. But my 2 here are red. Because if I look at this table, you'll notice rank ID and crew ID are the primary key. So multiple columns can create the primary key. You shouldn't do more than 3. I think 3 is the limit, but you never know if things go sideways. So now I've got this
All
relation.
right, I have a question on the multiple items. 'Cause I remember a while back that was something I was Googling about whether or not to do. And it was kind of like 50-50 because you can technically put in a primary ID there, right? But sometimes it's easier just to have the two combined.
And the reason why you put an ID there is if there was ever a case where these would repeat.
Okay.
So let's look at that. So let's look at Grand Cast Crew. So we've got Bob, who's currently an ensign, and he could get promoted, go through sergeant, return up there, but he might get demoted, right? So suddenly Bob might be busted back down to ensign. So here we're going to have a problem here because we're going to have Bob ensign twice. And we'd have two things we could do about that. We could either make the primary key those three things and the three columns, or we can create a primary key column called rank has crew ID. Crew rank ID, right? And then go here and uncheck these and then check that. Make sense? So the only time, again, the only time that these two couldn't be, I'm going to put it back that. Well, actually, that makes sense. The only time you couldn't use these two as the primary key is if they could ever be repeated. And since this is a rank table and we have a date attached to it, someone could be returned to a rank and busted back down. So that might happen twice. Now, next species. Here we got to here we've got to get rid of rank. Get rid of that. Next, species. Species is another candidate because species people might make stuff up or misspell something, spell Vulcan with a silent Q. So we're going to do the same thing here. We're going to make a species table. And we're going to do species. And they're going to species ID. And we're going to give it a name. And we're going to give it a home planet. And we're going to give it a language, native language. All right. So we're going to go back here. We're going to species. I don't think there might be 2 billion species, but I'm going to take my chances. I'm just going to go to a medium end because I think that's more realistic. We're only sticking, we don't go past the galaxy. So we're not going to find more than 2 million species out there. At least that can talk. Um, okay, so there's that, right? So then here's the question. How do we link crew to species? A crew member can probably only have one species. And a species could have many crew members. So it's a one-to-many relationship. So I'm going to take my one-to-many. Here's my one. Here's my many. I got it right in the first one. And now I have this relationship here, this little relationship here between species and that. It created a column here for me. So species ID. I can go back into here and get rid of species. And now I have my species table and I've got my crew table, and that is just there. Everyone with me? All right. I just love this stuff, so I'm enjoying this. I hope you're enjoying it as much as I am. Which is a lot to ask because I enjoy reading. Okay. Um, any other in the existing tables we have? Can you see any other thing that we need to make a separate table? I can see three.
I'm assuming department, you'd want a separate table so you can list off the different departments.
Yep. Plus, we don't want to trust people to type in their own department, you know. So we're gonna make a department table, and then we'll do a department ID. And we're definitely making that a tiny int because there ain't no way we're having more than 256 departments. That's just asking for trouble. Where's my tiny int? Where are you, buddy? There you are. No. And I'll give the department a name. And we're going to give the department the color that it wears. That's an important thing in Star Trek. Because if you're red, you're dead. All right. So, what's our relationship with department and crew? One to many or many to many?
I'd say many to many.
Many, maybe absolutely correct. So we go many to many because one crew member in the course of his career can hit many departments. One department has many crew members. So there's our many to many. And I don't, if for some reason, when you do it this way, it adds that species. You just got to get rid of that species. I don't know why. Okay. So now we've got department ID and crew ID, and we want to know the date. We want to put date in there. Date started. And then date ended. And this one can be null because they might be currently in there. Okay? But we're going to need to make an ID column for this because one crew member might revisit the same department over the course of their career. It might be engineering, then go to command, back to engineering. So we're going to do an ID. So we're going to do a department crew ID. We'll make that one a medium int. Who knows? Maybe there might be a lot of going back and forth there. That's what I get trying to type in. Where are you, medium int? All right. And we're going to make this the primary key, and we're going to get rid of these two guys. But we're going to make sure those stay not null, because that's important. Make everything here not null. All right. So here, I got to go here and get rid of the department. Suddenly, my crew is a very small table all of a sudden, isn't it? It's just ID, name, and if you survive, what your species is goes over here. And then we've got department, and department has crew. Any other tables? And keep in mind, 20 minutes ago, I just created this one table, and here we are 23 minutes, 13, 20 minutes later, and we got 5 tables, and we're still missing 2. What 2 tables do you think we're missing?
Home planet, maybe?
Home planet, absolutely. Yep, absolutely. Gotta do a home planet. We don't want to make stuff up. We just don't trust them. Being a DBA makes you very distrustful because you just assume that they're going to do bad things. Not because they're bad people, but just because they're not, well, they're not playing with a full deck. I mean, let's be honest, right? I mean, the adage in the world of computers is if you want to protect your computer, you unplug it. That's the safest way. No one else touches it. So you're gonna make it as safe as you can. So we're gonna make a planet table, and we get a planet ID. And we're gonna give it a name, and we're gonna give it a location, and we're gonna give it date discovered, date of first contact, date first. I am breaking a rule here. Do not put spaces in column. Date first. Okay. Okay, so we'll get rid of this one here. We don't need that one. Put selected. This will be the date. And this one, we're going to get all fancy. And we're going to make this one, we can make it geometry because that's technically location. But do they have? No. See, your other engines, your Microsoft SQL Server and your Oracle, they have coordinates. You can actually use it for coordinates. So I'm going to use decimal there because location will be decimal. All right, so that's good. And now it's going to be, is it one to many or many to many?
I think it's one to many, right?
One to many. It's going to be one to many because we're talking a home planet, so they started somewhere. Many, planet ID, and we'll go here and get rid of home planet. And actually, here's something you can do. It's not necessarily the best thing to do, but you can if you want to. So here I have home planet, right? And I can delete that. I can go here and change this to home planet. Generally speaking, that's not a great thing to do because when you look at here, you're like, oh, this comes from the species table. That makes perfect sense. When you look here, oh, this is home planet. I don't know that this is foreign keyed because the name doesn't say it's foreign. But you don't have to have the name to be the thing, right? You can call them whatever you want. But the standard practice is to make sure whenever you've got a column which is a foreign keyed column, which is what these are, that they match okay, that they match the name of the table they come from, just to make life easy. And here's the other thing about the planet table, right? So here we've got, I'm going to jump. I would do a native language, but it's almost 10:30, so I want to jump to this one, do away missions. So away mission, I would do mission ID, right? And then I would do name of the mission. I'm not getting around. I should be changing these into something else the entire time, but I'm running low on time. No. I'm sorry. Name, varchar 50. We're going to do start date. We're going to do objective. And we're going to give this another data type, a new one. We're going to give it text. Where are you? Text. Text basically just lets you put as much in it as you want, like a paragraph, a sentence, entire chapter of a book. And then we're going to call this stats. And then we're going to put in planet. Now, see what I did here. And this is why I want to do this. So over here, we did the species table, and the species had a planet. Now I have another need for the planet because away missions go to a planet. So I can do this. This would actually be a many-to-many because one mission might go to many planets. So I'm going to go back to my many-to-many. Find you. Many-to-many. So many-to-many. Put you down here. And this one we'll just leave as is because everything else we need to know is here for right now. So dates and stuff like that. So this planet table came in handy in two different places. And in 29 minutes, I've made 1, 2, 3, 4, 5, 6, 7, 8, 3, 9, 6, 9, 9, 10, because I got crew assignments. And I could probably make another, if I really wanted to and spend an hour doing this, I'd probably end up with like about 30 or 40 tables. Right? So here's the thing. That's how you make a database. You get your topic, you pick your first table, and then you go from there. And then when you've worked the entire first table out, you go, oh, I also need, like, say, oh, I need to do away missions now. Oh, okay, this needs this. I'd probably have a status table. I gotta get rid of this planet column here because that doesn't need to be there anymore. Selected, right? So I'd have a status table. I'd have to make one of those. I still haven't made my language table yet. And that's going to be many to many because there might be multiple languages on the planet. We don't know. And then crew assignments, that's going to give us a whole other thing. And then I had a table written down when I did my notes. I had a like an alien encounter table. Because just because I'm on the planet Vulcan doesn't mean I'm not going to run into Klingons. You never know. They might be there having a vacation. You know? So, but this is the best way for me to show you how this happens. It's you just got to follow. And I don't know if I've referred to this because I've changed all my stuff for this semester, but I always talk about the flow of data. Data flows. It's like artwork, right? So it's feng shui. You flow from one room into the next room. That's what you try to do. So data is the same way. I started here at the head of my river, and I went, okay, crew. Oh wait, here's I need a rank table because I don't want to trust Bob to put the right rank in. So I got to have this many. Here's another table. I can't trust Bob to put the right department in, so we're going to give him a department table, and then so on and so forth. Because when you're designing the database, you're thinking of the front end, right? So when it comes up, we're not going to have a text box for species. We're going to have a drop down, and the drop down is going to be powered by this table. The drop down for rank, the drop down for department, the drop down for planet are all going to be powered by these tables. So these drop downs are going to pull this information out for searches and for input. So if you've got a good solid idea of what you want to do, and you sit down for 25, 30 minutes and just start, riffing out either on paper or on here, the tables you need, you'll be in 10 tables within 25 minutes. Pretty easy. So, any questions on this? And again, my favorite part about teaching this class, coding is okay. Coding is like, doing coin tricks for children. Look, I made the data. I mean, we're going to there's some really cool, we're going to talk about case statements, which are pretty fantastic, transactions, which are awesome. I love a good transaction. But like select statements and joins, like, it's okay. This is. So any questions on the coding of a table, how to create a database? Okay. So I'm hoping this has inspired the three of you to do the final project. And it's going to be fun. Just come up with your ideas. I don't remember. My memory is shot. It's 10:30 on a Tuesday night, and I've already had to yell at 12 people a day at work. So I don't. My other job where I yell at people, that's my job, is to yell at people and tell them what they can't do with databases. But if you're doing, to the 4 people who are going to watch this, including the people here, I guess it wasn't very clear. The final assignment of the week where you do the code for possum databases, possum pets, that's the writing assignment. That used to be just write a paragraph, and I thought it was stupid, so I changed it. So now it's doing code and writing it. But if you're going to do the final project, just go there and tell me what you're doing. Don't worry about possum databases unless you want to do it. That's cool. But all that is there for. Tell me where you are with your. And I'll answer questions there, or ping me in any way to ask questions. But if there are no questions, I will release you back into the world from the sanctuary that is MySQL. And then I look forward to seeing you guys next week. So take care.
Thank
Bye.
you.
You're welcome. Thank you.
Thanks.
Thank you.